All right. Well, my name is Cameron. I'm with Cascadia Windows and Doors. I have my colleague here, Chris Guapa. He is also joining in. Make sure to keep me in line and all that fun stuff. I'm going to take you on a journey for the next hour or so, talking about high performance fenestration products, and we are going to dive right on into it. So the agenda for today is I'm going to give you a little bit of an introduction to myself, Cascadia Windows and Doors. From there, we're going to go into an overview of building performance and the changing of high administration products. And I have a handful of project case studies that we're going to tie into these high performance fenestration products categories and characteristics. So a little bit of a background on myself. I've been in the glazing industry for just over a decade. I started off in the the glazing contractor side, down in the shop, putting frames together, glazing them, and all that fun stuff. And I transitioned over to the manufacturing side and have been there ever since. Now, Cascadia Windows and Doors, they have been an industry leader manufacturer of high performance commercial family, a little bit of the residential, lots of operable sliding swing doors, but also a component of passive house as well. And then in addition to that, there's the side of the business, the space to low. More my biases lie, company's biases lie. We'll dive right on into this. So now we're going to begin our journey of beyond the frame. So really this image here is to give you a tale of two cities. Now, these are two different regions. In the U from south. Become this level of, and so what does that interior and cost of their energy bills and also largely is heating and cooling loads on these buildings. And so to maintain a comfortable interior, right, we're spending a lot of energy and carbon to do that. And so where is this energy going? Where is this carbon going? Essentially, it's going out the window and then out the walls. And so looking at buildings, existing buildings primarily, 30 to 50% of the building's heating and cooling energy is lost through the windows. And by simply changing the framing material that holds the glass in place, you can drastically improve the overall performance of the entire window. So I'm going to give you a little bit of characteristics on this, and I'm going to have you guess an impact. I'm going to give you what you're guessing here in a second. So this is a project that was built in the late 1960s, and then it was retrofitted per the passive house standards. This is called the Ken Sobel Interfit Tower in 2021. And so what do you think the annual heating demand was changed, or the impact of the change after the retrofit? I'll give you a second here to kind of think about it. They went from an existing building built in the 60s to the passive house standard in 2021. And so essentially the heating demand was reduced by 91% by this upgrade. They didn't just replace the windows, I will say. I'll go back a little bit. You can see here they increased the overall building envelope. They, added metal panels and added insulation, but they also did the windows as well. Now, passive house isn't commonplace. We don't see passive house all over the place. We are starting to see it more, but it's not the standard building methodology we see. So let's look at the impact on a more standard building that we might see a retrofit on. This project is called Meridian Cove. It's located in Vancouver, British Columbia. It's an 11-story multifamily residence. And they did a rehab project where they replaced the non-thermally broken aluminum windows to triple glazed windows. And then they took and they added some insulation and some metal panels on the outside, or some exterior cladding. And so what do you think? Nobody saw that. What do you think the overall impact to the occupant's energy bill was after the rehabilitation? Unfortunately, I spoiled it, but the improvement, the reduction in the energy bill was roughly about 60%. And this is year-over-year reporting data that they're seeing this. Now, something to keep in mind in this is for their overall energy bill to decrease 60%, there are a lot of constants that didn't change, right? You have your appliances on the interior, you have your lights, you have your electronics that are still running. So your HVAC system drastically decreased to get an overall energy bill reduction of 60%. And so dialing this back even further and looking strictly at the window components. When you have a thermally broken aluminum window and you change just the framing material, you're not changing the glass, just changing the framing material. By switching to a high performance fiberglass framing, what do you think the impact is to the overall thermal performance of the holistic window? It is roughly about double the thermal performance that you get out of changing just the framing material. So you're drastically improving the thermal performance of that system. I do see there is something in the chat here. Just want to make sure. Oh, sorry, Robert, I missed your 50% guess there. Alrighty. So what does this mean for our buildings? Well, by improving the thermal performance of our windows, we are able to improve the overall building performance with our windows being the weakest link. Now, what is the impact of this and why is this important? Well, the importance is we are starting to see regulatory changes, the response to needing better performing buildings to reduce our carbon impact. We're starting to see this with the BC Step Code. We have the New York Law 97. We have the Massachusetts Stretch Code, the Vancouver Emissions Reporting, and also the Energize Denver, which is another similar reporting agency, which is these are more of the stick, if you can think of the carrot and the stick analogy. And so a lot of these are looking at requiring buildings to perform better so that we can get to reducing our emissions. In addition to that, there's a lot of incentivized performance options, and these are municipalities that also offer those. Those can look like an additional zoning square footage, subsidies, preferred banking rates. And so these are just options for architects and owners to design their buildings better, that they're being incentivized to do so. And in response to that, the industry is providing product innovations, voluntary corporate reporting, transparency data, EPDs are being provided, and education. And so with all of this and the requirements for buildings to perform better, we need to adjust how we look at and update our view of how we're looking at windows. And what I mean by this is there's three buckets I'm going to kind of divide this up into. There's the whole building approach, looking at how the overall building is working together and how the window component is a part of that. Excuse me. characterizing what a high performance window is. So I'm going to give you some characteristics of a high performance window. And what we really see as being some pretty key components for making a window high performance. And then lastly, integrated components into the window system. Window systems are starting to be able to offer more than just the traditional glass and frame. And what this does is this offers opportunities to reduce penetrations into your weatherproofing. This offers less thermal bridging into the back to structure because you're tying into the window system. And we'll talk about that and what these best practices of also how they improve building performance. So starting with whole building approach. Traditionally, the way we've looked at building code is we've had realistically a recipe with instructions of like your windows are going to hit X R value, your roof needs to hit Y, and your walls need to hit Z. And so this is like having a recipe without a full set of instructions to hit the best performance for that building. Newer building codes are taking a look at the overall building and its overall performance. And so you're given a allotted amount of energy that building is able to use. And however you design said building just needs to hit this energy value or better than it. And so what that gives is design flexibility for the architect and the owner as to what they are able to do. Next, we're going to look at the key components of a high performance window. To start, we're going to look at the glazing. So generally speaking, triple pane glazing is thought to be of the higher or highest performing IGU in that window. Next, having warm edge spacers drastically helps with the thermal performance. Reduces the thermal transfer with the IGU into the frame and then into the internal side of the building. Multiple gasket points. This helps with air infiltration and then drastically reduces the transfer of energy into the building. Let me just see, there's another comment here. An IGU is an insulated glazing unit. And so it is essentially what you see here, multiple panes of glass being put together into one unit. And so insulated glazing units is, you have double glazed or triple glazed. And that's just the term that is used to describe that. Next, after multiple gaskets, is the insulated frame. And so having an insulated frame and a low conductivity material drastically reduces thermal transmittance through that into the internal side of the building. Multi-point locking really engages the compression on the gaskets and reduces air infiltration. And then minimize frame area. Everybody wants to have the nice sleek windows. They want the design to be as least impactful in the building, but that also helps with the thermal performance as well and reducing the area at which thermal transmittance can happen through the frame. So for my visual learners out there, this is a modeled building, just a mid-rise building, aluminum window wall, thermally broken, and with a window to wall ratio of about 40%. Now, Teddy and TUI is your metric variation of this, but essentially it's looking at the EUI, the energy usage intensity of this building. And so with your traditional building, this building meets code, but it is barely scraping by. You're not winning any awards for this building. It's just barely meeting what it needs to. By simply changing the framing material, you are able to get more for less. And what I mean by that is you're able to get more window to wall ratio, which drastically gives you more flexibility. You don't have to use all 65%, but it gives you the ability to go up to that and design based on the use case of your end owner. In addition to that, you're able to reduce your EUI, so you're improving the performance of the building because you've improved the weakest link in your building. What this means is you get better views, you get more views, you can introduce more natural light. There's the potential to reduce the mechanical system, right? If you drastically improve your thermal performance, you may not need as big of a mechanical system in terms of vents, ductwork, but you also just may not need as big of a unit because you're not losing as much energy through the window system. This might increase your usable floor space. Not only the thought of like having heat exchangers by the windows, but having a window that's comfortable enough to sit by, to set a table and chairs by and not be impacted by the exterior extreme conditions. This might help you reduce installation requirements elsewhere. You know, if you have some tricky details that are going to impact your performance, if you improve your weakest link, these tricky details become a little bit less worrisome. And it also reduces the need for additional insulation based on your modeling. There's the potential for cost savings as well on the installation side of this. And this is more so to do with the weight of the units. So traditionally, triple glazed units are quite expensive to install because they're just so heavy. And that's because traditionally aluminum framed systems to hold the triple glazed unit are just a very heavy system. And by switching to a fiberglass system, you're able to reduce your weight. Your installation costs can decrease in some instances. And then lastly, your future operating costs in dollars and in carbon, right? You're saving money on your electricity or heating bills, but you're also emitting less CO2 into the atmosphere to do so. Lastly, in this bucket, we're going to look at integrated components. And this looks like a couple of things. So firstly, you know, this is a very traditional window insulation detail, right? We're sitting right on top of structure. We've got our exterior insulation out front. Typically, we have some flashing details that cap that insulation, but our window is typically inboard of the insulation. This proposes some weak points for thermal performance, right? We have structure that is semi-exposed, and you have the frame that's conducting into the structure. Ideally, we would like to have the frame, the window frame and the window a little bit further out into the insulation cavity. This helps maintain or keep the hot air or cool air in and the opposite on the outside out. Just drastically improves better performance, but it's a tricky detail, right? Right now, the way this is shown is we have a window floating in space, which is not necessarily ideal. So ways to combat this. This has taken us back to the Ken Sobel Tower, the Interfit project. On this one specifically, they engineered a fiberglass L angle to support the window in the installation space. This drastically improved the performance of the windows and the overall building assembly, but it also was not necessarily easy, right? We had to do quite a bit of engineering and a custom angle for this. So what if we could utilize something that's a little bit more off the shelf? It allows for this similar detail where we're out into the installation space, right? We're drastically improving the performance, but maybe not having to do something so custom on future projects. And we're able to do so. So this is an example of a thermal spacer system for exterior cladding components. And so what we're able to do now is take these clips per se and support the window system above and integrate into the cladding components below. So what you see here, the purple clips are supporting the window system above. And so you can see above that, there's the L angle, the window system sitting on top of that. And then below it in the gray, you'll see the cladding components. And this is your exterior wall cladding component, your metal panel, stone panel, whatever you have going on up front there with the insulation cavity behind. And this is what the detail looks like from the side. You can see the window support there. And what this does is it allows for the integration into the installation space, tying back to structure. That's the strap anchor allows for us to attach back behind the window system. And then you're reducing your thermal bridge and tying into your cladding component system up front. Now, this isn't something that's just a dream or dreamed up and hoping to be used. It's being used right now. So there's a project called Gladstone Village in Ottawa, Ontario, and they are using this very detail. You can see down below the window out front there, those purple clip looking deals is the clip system, and it's supporting that recently installed window. Another integrated component that we often see that is not tied into the window system is your Juliet balconies. I would say that they are starting to become a little bit more popular as buildings need to hit better performance and they're going away from your traditional balcony. but still wanting the desire to have fresh air, access to fresh air from your unit. And so we're starting to see a higher demand for that. Traditionally, Juliet balconies have been attached to structure. You usually have penetrations through your air and water barrier, potential thermal bridges back to structure. And so this integration into the window system reduces those other penetrations, reduces thermal bridging aspects of it, while also reducing the visible sightline of it. So it really improves both the visual aspect of it, along with the potential for penetrations into your exterior wall. And here's an example of it being used on the Cole Harbor Passive House project in Vancouver, BC. This is probably one of the largest passive house projects in North America. So it's going to be pretty exciting once they wrap it up. All right, now we're going to hop into the case studies. And keep in mind the three kind of different categories we touched on there as we go through these different project case studies. And so the first project is the Art Rutkin Elementary School. This is roughly an 80,000 square foot mass timber net zero ready school, and it's in Tigard, Oregon. So Bora Architecture was the designer on this, and they had two key elements that they really needed to hit on this. First being they wanted a biophilic design with lots and lots of natural light. And they have it's mass timber, so they're bringing natural elements into the building, really important for this project. The second one is being net zero ready. They wanted to be ready to hit net zero without having to add a bunch of additional stuff down the road. They wanted the building ready for that. And so what that meant for them is they needed a lot of natural light, nice large windows, but still hit a nice solid thermal performance. And so what you see what they did here is they did a curtain wall-esque style of window glazing, but they did it with a storefront style installation. What I mean by that is instead of having a curtain wall that spans multiple floors and is relatively expensive to install, they broke these up while still giving the look of a curtain wall, really open the space up. These are not small units, right? They're just under 10 feet tall in some areas, but they were able to maintain a higher performance, right? So drastically outperforming the aluminum counterpart while still giving the size that they wanted. Now, they might have been able to, actually, I'm getting ahead of myself here. How many folks are familiar with how fiberglass protrusions are made on the commercial side of things? I'm sure a handful of you are familiar with aluminum. So real quick sidestep here. So aluminum is essentially they take a billet, a nice giant piece of aluminum, they superheat it, push it through a die, a shape is pushed out on the other end, it's tensioned, heat strengthened. That's how aluminum gets its shape and its strength. Fiberglass is ever so slightly different. So essentially they take a bunch of fiberglass strands and they spread them out, they coat them in a resin, and then it's pulled through a die, hence pultrusion. And that die is gently heated. And with that heating process, it sets off a chemical reaction, which gives the fiberglass pultrusions their strength, and it being a thermoset polymer. And so with that chemical reaction, it is once it's in that shape, it's in that shape. It's not going to change. You can't heat it up to a temperature and get it to change its shape. It is inert in that aspect. And so the properties of that and the strength of that pultrusion process gives the lineals, they were able to hit the height that they needed to. They might have been able to hit the thermal performance needed on that project with a vinyl window, but the sizes they were trying to do, just under 10 feet on some of them, would have been a bit of a stretch for vinyl by itself. And so then they most likely would have had to have introduced steel reinforcing. Now, when you introduce that, it drives costs up, it drives your thermal performance down, which makes you start to wonder why you would want to go down that road. The next project we're going to take a look at is Pacific Promenade. This is a renovation project that as they were going through redoing the envelope, they wanted to get the most bang for their buck. on their renovation process. They were going through the pain of having to do this reno project and replace their whole facade. They not only did they replace the windows, they replaced all the cladding components around it as well. This project was built in the early 90s. And a unique thing with this project is they were able to drastically improve the performance by just going to a high performance window and double glaze. They didn't need to go all the way up to triple glaze, even though they have the option to. So this project utilized a couple different window systems, the fiberglass window wall system, some punch windows, operables, along with that. And so they're able to achieve an R value of roughly about 4.1 on this project with the double glaze system. They didn't opt to, but they could have gone all the way up to an R7 with the triple glaze. At their spandrel bypass, they're able to get to an R8, which is pretty solid for a bypass. And for their back pan and opaque areas, they're able to get to R16, which is very solid for a window, right? That's almost, that's a little bit higher than your standard ASHRAE 90.1 wall requirement. And so another option they would have had, potentially, is vacuum insulated glazing. And so what vacuum insulated glazing is, it takes two tempered units, and you have them spaced off of each other with very tiny spacers, and you seal them and you suck all the atmosphere out of them. And it creates a very, very good thermal break, essentially drastically improving the thermal performance of an IGU or just a standard pane of glass. And so this gives you the option to drastically improve the performance by simply just changing the glass. Now, not all projects are great use cases for this. Really, you have a couple of key factors you have to keep in mind, right? The window framing has to be in good condition. Your wall structure has to be in good condition, right? The prerequisite really needs to be that, like, all else equal, the only thing we really need to increase is the thermal performance. The air and water is performing fine, building structures in great standing. We just want a better performing window. That is a really good use case for a VIG. And in other use cases, mainly for newer builds or for retrofit projects, primarily in like some pretty extreme zones, is a VIG IGU with a high performance window. This drastically increases your R value. Now, this is most likely not going to be a very high use case for a lot of places, but maybe for your more extreme climates, your more extreme applications, it's a tool that's in your tool belt that you're able to pull from. Now, on Pacific Promenade, which was a very interesting thing on this project as well, is the insurance company for the HOA, or they call them stratas there in Canada, came to the contractor and the owners and said, if you test this during the process, the air and water tests, and a lot of them, we will give you a discounted rate on your insurance premium after the project's completed. Because you have to keep in mind, they're on the hook for replacing this facade. And their thought process is, well, if they test the heck out of this thing, we probably won't have to come back and replace this thing again in another 20 or 30 years. And so we were approached when we did this project. Do you guys have issues testing this? And we said no. And we went ahead and they did a lot of tests. They did 7 tests, which is a lot higher than what we see typically. I'd say that on average, you usually see 1 to 3 tests, on-site tests. So this is over double that. And the reason we were comfortable doing that is we already test our systems. Roughly about 10% of all units made get tested. So we were very comfortable with that, and that wasn't a concern. But what this did is it gave the owners a way to have a cheaper insurance premium that the insurance company offered up. And we definitely think as the rehab side of this industry grows, that's probably going to become a bit more prominent as insurance companies have to start paying for replacing facades. In addition to this, we also felt quite comfortable with it because we had done multiple and extensive tests on the system. Aside from just water and air testing, we've done a full-on PMU, and we were able to test it against the building movements, high air and pressure loads on it, temperature differential changes. So we felt very confident that we were going to be okay having the multiple tests done. The next project that we're going to talk about as a case study is the thesis head office building, or their headquarters. Now, this is a 40,000 square foot LEED Gold targeted project. Lever Architecture was the architect on it, and it's a mass timber structure. Now, two things were important with this one: lots of natural light and longevity. And so with the natural light, this one you can see here as we're flipping through, just nice large openings. It features windows from all the way from 57 inches wide and 131 inches tall to windows that are 118 inches wide and 143 inches tall. There's some really big windows on this project. And in addition to that, they really wanted to maintain the high water performance for that glazing. They wanted to ensure that since Thesis was going to own this building, that this asset was going to stay and maintain its value through time. So longevity was very important for them when looking at this. And what does longevity mean, right? So longevity and durability has a couple of components to it. One of them being how well the window performs over the life of the window. One of those factors has to do with the coefficient of expansion and contraction. In California, I'm sure you see this. In my local area, I'm in Colorado, we get massive temperature swings, right? We'll have the temperature get up to about like 80 to 85 degrees during the day and then drop down to 40 degrees at night. And what that means is the window frame is expanding and contracting around the glass, and it's putting extra stress on your seals and your sealant around the window. And so enabling the window to perform longer increases the protection it gives to the rest of the facade. So here's an example of a glass top that has shrunk, right? So temperatures dropped, glass top is shrunk. Now there's an opening for water, if it starts to rain or to snow, to enter into the window where it was never intended to enter through. And then on the complete opposite side, you'll see the right-hand side picture here is a window that got heated up so hot that it started to plasticize and deform permanently. Now, this window may close still, but is it going to get the same air and water performance that it got when it first was installed? Most likely not. And that's a concern for building owners who are going to hold onto their building and maintain their building. And the last thing they want is this. And so these are images from an event called the Leaky Condo Crisis that was in Vancouver, BC between the late 90s and the early 2000s, where essentially a lot of condos rotted out from the inside due to poor weatherable conditions between the window systems and the cladding components. And so they really wanted to stay away from that with this. And so they went towards the high performance window to ensure that. The next project we're going to take a look at is Lincoln High School. This is in Portland, Oregon, another Bora Architects project. With this one, the two key components for it were lots of natural light. Again, it's a school, right? Got to keep the students awake, got to have that natural light in there, but also longevity, right? The school is going to own this building for a long time. This is an asset held by the public municipality. They want to make sure it stays and maintains its performance throughout. This was a LEED Gold project, and it's a six-story urban rise project. You can see lots of natural light that they're wanting to let into the classrooms. Now, when we talk about durability and longevity, there's another side of it as well. How long is the window going to last? Now, I will have a caveat here. There is not wood framing here. And the reason we do not have wood framing here is a couple of reasons. A, it's hard to calculate its longevity because of the different environments drastically impact its longevity. If it's a very humid environment versus a very dry environment, if it's a large temperature swing environment versus not, there's just so many factors that go into it. Compared to the others that it's kind of skews and makes it a little bit harder to get good data on. So we went ahead and omitted it from this. The other side of it is we just don't see too many wood windows on commercial projects anymore. It really steers towards the composites and metals on that front. So now that we've covered that, looking at longevity, right? So we think about the lifespan of the window, right? If you're an owner, you put a window in, how long do you expect that window to last, right? So for UPVC vinyl, the lifespan is roughly about 10 to 30 years. So if you're a building owner and you're, for lack of a better term, stuck with your building to the end, and that's going to be your, your municipality buildings, your state buildings, your any government building, right? You're stuck with that building or until you take it down. And so longevity is very important. The next one is aluminum. Aluminum is pretty solid option here, right? 30 to 45 years, and there's multiple instances where it goes longer than that. Now, these are really looking at how long can the window stay in there and still perform to the level that it was intended to, right? Because I know that there are multiple buildings out there where aluminum's, maybe 60, 70 years old, but is that building still performing as it was intended to or not? And then there's fiberglass. Fiberglass is a inert thermoset polymer window framing material. It is modeled to last 50 to 80 years. Now, there hasn't been commercial grade fiberglass out there for 50 years, but over the last 20 to 30 years, it is looking like it is going to live up to the modeled length that we intend it to. So that's pretty exciting for longer life owners. And the other aspect of that, the cost, right? So the cost of the window definitely plays a role in the life cycle of the building, right? So looking at specifically fiberglass and vinyl, the vinyl or the UPVC window may be initially cheaper to install, but over the life of the building, if you just have to keep replacing it over and over again, the impact of that dollar-wise adds up over time, right? But it's not just in dollars. Okay, we have a cost of carbon as well. The cost to renew the product or remake the product on the carbon side of things, the energy side of things, drastically increases the more times you have to replace it, as shown here. And then lastly on this point, looking at the embodied carbon. So we had a client that was going through and modeling the impact of embodied carbon on a project, and they were looking at high performance fiberglass framing versus aluminum. Now, this was before the new EPDs were released and stuff, and we anticipate that based on the new EPD data that this is probably a more conservative and they're probably going to see better values than this. But just by looking at the initial estimates of this, the higher performance framing gave better savings for your embodied carbon. And that's something for some owners and some architects is a very important thing. And when we talk about EPDs, it's key to ask about the data. It should be available, and just ask the manufacturers for the data. They should have that and they should be able to share that. The next thing is the PCR. Make sure you're looking at the most up-to-date product category rules. Check the date. Make sure it's actually like up to date and it's not a very old expired one that's no longer valid. And lastly, confirm that you're looking at two equal things, right? One might be from cradle to gate, while the other might be from cradle to grave. And it was look at two different things. And so it's important to make sure you're looking at EPDs equivalently. Here's just another shot of the Lincoln High School. Next, we're going to talk about district office. Now, this one is unique in that they really wanted a lot of natural light. It's another mass timber project. Now, with this one, you can see they're doing floor to ceiling glazing. This is a really great example of nice large openings, looking for high performance. You can see here on the left-hand side, just under 14 feet on that storefront span. And on the right-hand side, we have like an 81-inch awning window. And that's just, about 130 inches on the right-hand side there. So it's pretty big openings. Now, with that awning, right, you're looking at the performance of this. We want high performance windows. And so a key component of that is the hardware. And when you think of a nice big awning, one of your concerns is, or any operable that's large, is that going to perform for your air and water performance? And so a key component of that is the hardware. Essentially, we look at hardware as a component that, a lot of times we're looking at just the lever handle or just the roto crank and the colors of that and making sure that that's aesthetically pleasing. But there's more that goes into it that's really important. You have your locking mechanisms inside the framing that engage your multi-point locks and making sure that those are high quality products that can withstand multiple use cycles, right? This project specifically is an office building. So you have the potential for somebody opening that window on a very regular basis, and you want that window to perform from the day it was installed to the end of its life cycle as best as it can. And to ensure that, you need to have high quality hardware. The last project example I'm going to be touching on here is the Chippendale Road project in West Vancouver. Now, this is a row of houses here. It's up the hill from the ocean. So you have, harsh environment from the ocean. You have, in addition to that, you're starting to climb up towards the mountain. So you need a high performance for that aspect. You can kind of see this a little bit better of a shot here of it. So with this, they had not crazy ambitious goals for high performance, but still pretty solid thermal performance goals on this project. You can see the glazing on this is pretty decent size. I want to say these were roughly about 8-ish feet tall for some of the shorter ones, and some of the taller ones were a bit taller than that. And they were really trying to open up that view to the ocean from the mountainside while still maintaining the performance they needed on that air and water, in addition to the thermal performance. In addition to this, something that is becoming a bit more prevalent is the wildland urban interface, where we have buildings that are starting to creep into the wildland area. Like, this is by no means the middle of nowhere. It's a suburb in Vancouver, but it is also right up against the forest. You can kind of see there with the pictures on this one, but also back here, like they're backed right up against the forest. And I don't recall the exact month or whatnot, but there was a forest fire up and over the hill on this that fortunately went the other direction, but very well could have come down the hill. And the fire resistance of the buildings would have been a very, very key aspect to this. And part of that is your frames. So traditionally, the characteristics we've graded frames on, graded windows on, have been 4 key ones. One being strength. How much can you span? How strong is it? How big of windows can you give me? Next being thermal performance. How well do you perform thermally when you start to get into needing to perform better to hit higher standards? Third being longevity. How often do I got to replace this window, right? I'm putting in a window. We're spending a ton of money on this building. I don't want to have to come back in 15, 20 years to replace it. So longevity is another really key one. And then the carbon impact's starting to pick up as being a more popular grading factor of window products. And so traditionally, we've kind of graded windows based on their strengths and weaknesses on this. And as of recent, we've really started to look at wildfire resistance. Now, this doesn't mean the frame is fire rated. This is more so, how does the frame handle in a wildfire instance when you have a wildfire nearby and you want to make sure that your building is as best protected as you can. Now, I won't spend much time on this. We have a whole other webinar presentation on this. Here's a sneak peek of what that would look like. If you like to see people testing fire stuff, this is definitely for you, but it's something that is becoming more and more important for people, especially on the wildland urban interface. Some key takeaways, then we'll dive right into questions. So windows have a huge impact on your overall building performance. They are often the weakest link of your building, and it is important to take extra care with deciding what window material you're going to go with for your overall building performance. Pay attention to your product details. All right. Is the window you're specifying, you're picking, you're modeling, you're building off of, has it been tested? Right? Are you working off of tested data or hypothetical data? And then lastly, high performance equals high flexibility. When you are able to hit higher performance targets, it allows for you as the designer to have more flexibility in what you do with the building, because you're not just barely scraping by and meeting the bare minimum. You're able to go above and beyond, and it allows you to have flexibility in your design elsewhere in the building. All right, I think we got through there. Got about 11 minutes left. Are there any questions?
There are no questions in the chat right now.
Oh, Robert's got his hand up. Go ahead, Robert. Or is that clapping? That might be clapping.
That was me trying to ask a question.
Oh, okay. Yeah. No, yeah, go for it.
They're going to ask. So this is excellent. Thank you very much. Just a question though, in terms of costs, how do the costs bear out with Windows? I mean, I really love the material and the products. I work with existing buildings, and they shy away from these projects because of the cost. And I would hear in the industry, I literally would hear energy efficiency leaders say Windows aren't worth it. So
Really?
oh yeah. I mean, in past years.
Yeah, okay. Yeah, it's interesting because they're often seen by a lot of folks as like the weakest link on the building. I mean, as window suppliers and manufacturers, we even also call them the weakest link on the building, because they are. You have a hole you want to look through, right? So it's interesting that people think that they get overlooked, I guess you could say. In terms of cost, I will say that it drastically depends on the configuration. And so let me see if I can pop to a couple of examples. And so what I mean by that is when you're looking at a project and you have large openings, right? So you have a nice large fixed opening like these, or a large operable opening, the price starts to get more competitive than if you were to have a lot of horizontals added in unnecessarily, like more so for aesthetic than needing for structure. When I coach people on how to kind of get the best optimized look, we really push people towards something like this project here, this Eagle River Residence in Anchorage, Alaska, where you just have nice large openings, and it reduces your cost impact for those windows. This design really drives your square foot price down and gets it into a more reasonable range. When comparing them with like other materials, so with vinyl, similar to that slide I had prior, if you have an owner that is looking strictly at, I need the bottom dollar type of deal, we're not going to be able to compete with just the initial cost. Our selling point really is on owners who are, we are going to own this building and we want to get something that's going to save us money over time with performance and renewal cost. With aluminum, it is very strongly dependent on the configuration. And so operating costs come into play if you have an owner that's looking at that, but also just the configuration of the windows. And if it's, again, like if we're able to do nice large openings, we compete very well. When you have, I had a project that we looked at that they had 4 random horizontals in an opening that was like 8 feet tall. And it was very expensive. And we were able to kind of coach them away from that to get it more into their budget. So it really depends on configuration against aluminum.
Great, thank you.
Yeah. Are there any other questions? Hopefully.
And I think, Cameron, maybe if you could just show people if they do want more information, just give them a quick view of the website where they can download information, or if they're interested in additional education, or to contact us would probably be a good one to highlight.
Absolutely, yeah. Yeah, so at our, especially for folks that are interested in the wildfire, if you go to our webinars tab here, you'll see what's upcoming based on the design or the topic, I should say. So the wildfire design, the next one we have going, I think it's later next, actually that's this Friday, right? So we have multiple webinars going on. You can see multiple to register for, along with if you're wanting to see the last one that was done is on there. Contact us. I think that's into the company. Yep. You can type in good old California and you'll see that should have my contact info. Yep, it does. There I am. But yeah, no, I think that these are two areas. And then if you're curious about the different systems, you can go to the appropriate page up here.
And I will just comment for anyone that is interested as well, all of the profile details you can download without registering, anything like that. So if you're interested in more information, you just scroll to the bottom of the page and click download, and they're available to you. We typically get comments of, "Oh, thank goodness you didn't make me register just to get the information that I wanted." So it's all there, and if there are other bits of information that you'd like, as Cameron said, please reach out.
Yeah. All right. Any other questions out there? Hopefully you're not too shy. All right, well, we will hang around. But Sydney, do you have anything you would like to add?
Nothing from us. Just thank you guys for this presentation and thank you for everyone who was able to make it. We'll be posting the recording to our YouTube channel in the next day or so. So if you missed any part of it or you want to review it, it'll be available there. Thanks, everyone.
Wonderful. Thank you. Oh, Robert.
That's a clap.
That's a clap. Okay.
That's
Nice.
a clap.
Nice.
Smiling clap.
All right.
All
Thank you.
right. Have a great rest of your week, everyone.